Hello and welcome to section 11.5, Dividing Radicals. The fundamental ideas from this section are involving rationalizing a denominator, in which we multiply both the numerator and the denominator of a fraction by a radical that will result in the radicand in the denominator becoming a perfect power. This will remove any radicals that we have from the denominator. We know that a radical is fully simplified when no perfect powers are factors of the radicand and all exponents in the radicand are less than the index. It is also fully simplified when no radicand contains a fraction. The third way that we know that a radical is fully simplified is that no denominator contains a radical. Example 1. Let us rationalize the denominator for 3 over the square root of 3. Since the denominator is a square root of 3, we know that the square root of 3 times the square root of 3 gives us 3. Therefore, we multiply the numerator and the denominator by the square root of 3. This will remove the radical from the denominator, and we have 3 over the square root of 3 is equal to 3 times the square root of 3 divided by the square root of 3 times the square root of 3. In the numerator, this gives us 3 times the square root of 3. In the denominator, we have 3. We then cancel 3's numerator and denominator to leave us with only the square root of 3 as a final answer. For example 2, let us rationalize the denominator for 10 times the square root of 3 over the square root of 2. Again, the denominator is a square root, so we have the square root of 2 times the square root of 2 equal to 2. Multiplying both the numerator and denominator by the square root of 2, we have 10 times the square root of 3 times the square root of 2 in the numerator, divided by the square root of 2 times the square root of 2 in the denominator. Using the product property for radicals, in the numerator we have 10 times the square root of 6, and in the denominator we have 2. Canceling a common factor of 2, numerator and denominator, leaves us with a final answer of 5 times the square root of 6. For example 3, we will rationalize the denominator for 2 over the cube root of 3. Because the denominator is a cube root, we in fact have the cube root of 3 times the cube root of 3 squared gives us the cube root of 3 to the third power. The third power cancels the third root, and we are left with 3. Therefore, we need to multiply the numerator and denominator by the cube root of 3 squared. This would give us 2 times the cube root of 3 squared over the cube root of 3 times the cube root of 3 squared. In the numerator, we take the exponent on the cube root to the inside to give us 2 times the cube root of 3 squared divided by the cube root of 3 cubed. The cube root of 3 cubed gives us a 3 in the denominator, while the cube root of 3 squared in the numerator becomes the cube root of 9. So that we have a final answer of 2 times the cube root of 9 over 3. Let us continue with example 4. We wish to rationalize the denominator 12 over the 9th root of y squared. There is a typo here, and that is supposed to be y squared. As our first step, remember that we have the relation the 9th root of y squared times the 9th root of y squared to the 8th power gives us the 9th root of y squared to the 9th power. The power cancels the root, and we have simply y squared. Multiplying the numerator and denominator by the 9th root of y squared to the 8th power gives us 12 times the 9th root of the 8th power, 9th root of y squared to the 8th power, divided by the 9th root of y squared times the 9th root of y squared to the 8th power. This gives us, switching the power from the outside to the inside of the radical, we have 12 times the 9th root of y squared to the 8th divided by the 9th root of y squared to the 9th. The 9 cancels with the 9 in the index to give us a y squared in the denominator, so that we have 12 times the 9th root of y to the 16th over y squared. Simplifying the radical, this gives us 12 times y times the 9th root of y to the 7th power divided by y squared. Canceling a common y, numerator and denominator, this gives us 12 times the 9th root of y to the 7th power divided by y. For example 5, we wish to rationalize the denominator for 3 over the square root of 2 plus 1. In this case, we have a binomial in the denominator. In this case, we use the conjugate to simplify it. The conjugate of a binomial is obtained by changing the sign on the second term of the binomial. In our case, we have the binomial square root of 2 plus 1, so its conjugate will be the square root of 2 minus 1. Expanding these out, we are left with the square root of 2 squared minus 1 squared, or simply 2 minus 1, or 1. This should remind you of the difference of squares. It should remind you of this because it is the difference of squares. Multiplying the numerator and denominator by the conjugate gives us 3 times the square root of 2 minus 1 in the numerator divided by the square root of 2 plus 1 times the square root of 2 minus 1 in the denominator. Multiplying the denominators out gives us 3 times the square root of 2 minus 1 in the numerator divided by the square root of 2 squared minus 1 squared in the denominator. Simplifying this further, we have 3 times the square root of 2 minus 1 in the numerator divided by 2 minus 1 in the denominator, or 3 times the square root of 2 minus 1 over 1. But this gives us a final simplified answer of 3 times the square root of 2 minus 1. As a final problem, let's simplify the square root of c minus d over the square root of 2c plus the square root of 6d. Again, we have a binomial in the denominator, so we look to the conjugate. The conjugate of the denominator is the square root of 2c minus the square root of 6d. Multiplying these terms out gives us the square root of 2c squared minus the square root of 6d squared. But this simplifies as 2c minus 6d. We then multiply the numerator and the denominator by the conjugate so that we have the square root of c minus d over the square root of 2c plus the square root of 6d times the quantity square root of 2c minus square root of 6d over the square root of 2c minus 6d. Now with example 6 continued, we multiply the numerators to give us the square root of c times the square root of 2c minus the square root of c times the square root of 6d minus the square root of d times the square root of 2c plus the square root of d times the square root of 6d. Using the product rule for radicals, we have the square root of 2c squared minus the square root of 2cd minus the square root of 6cd plus the square root of 6d squared. All of this is over 2c minus 6d. Simplifying this a bit further, we can take the square root of the c squared to give us c and the square root of the d squared to give us d. Therefore, we have a final answer of c times the square root of 2 minus the square root of 2cd minus the square root of 6cd plus d times the square root of 6. All of this over a final 2c minus 6d.